Hello, dear children, and welcome back to the class. Dear friends, today we are going to learn about the modern periodic law. Earlier scientists assumed that the properties of elements are periodic functions of their atomic masses. On the basis of their assumptions, Mendeleev placed 63 elements in a vertical column called groups and horizontal rows called periods. This method was rejected as it could not explain the position of certain elements, rare earth metals, and isotopes. A scientist named Henry Moseley removed these defects and put forward the modern periodic table with the modern periodic law. So, what is mean by modern periodic law? Modern periodic law stated that the properties of elements are a periodic function of their atomic numbers. This is nothing but the modern periodic law. Let's begin with the modern periodic table, which is also called the long form of the periodic table. The children, a tabular arrangement of elements in groups and periods which highlights the regular trends in properties of elements is defined as the periodic table. In a modern periodic table, there are 18 vertical columns known as groups in the modern periodic table, which are arranged from left to right, and 7 horizontal rows which are known as periods. The children, group first is also called the alkali metals. Alkali metals can form strong alkalis with water. Group second is also called alkaline earth metals. Alkaline earth metals forms alkalis but weaker than group first elements. Group 13, which is also called boron family. Boron is the first member of this family. Group 14, which is also called carbon family. Carbon is the first member of this property or of this family. Group 15, which is also called nitrogen family. This group has non-metals and metalloids. Group 16, which is also called oxygen family. Oxygen are also known as chalcogens. Group 17 or halogen families. The elements of this group form salts. Group 18 or zero group elements. They are noble gases and under normal conditions they are inert. Elements of group first, second, 13, 14, 15, 16 and 17 are known as the main group elements or normal elements. The elements of group 3rd, 4th, 6th, 7th, 8th and 9, 11 and 12 are known as the transition elements. Group 18 is called noble gases or inert gases. Their outermost shell is completely filled. Due to this stable electronic configuration, the inert gases generally do not react with any other element. Dear children, when we talk about the periods of a modern periodic table, one should keep in the mind that the number of shells present in an atom determines its periodic number. The elements of period 1 will have only one shell. Elements of period 2 will have two shells, and so on. The first period of the modern periodic table is the shortest period, as it contains only two elements. The period number 2 and 3 consist of 8 elements each and is known as short groups. Period 4 and 5 have 18 elements and are known as the long group. In the modern periodic table, group number 3 of period 6 contains the lanthanide series, which are the rare earth metals, which have radioactive element actinides present in group 3rd of period 7. So, we have seen here the properties of the modern periodic table. Dear children, which elements belong to group 15 of the modern periodic table? In the modern periodic table of elements, nitrogen, phosphorus, arsenic, antimony and bismuth, these elements are collectively referred to as the nitrogen family. What trends in electronegativity can be seen in the modern periodic table of elements? In the modern periodic table, the electronegativity of elements increases across the period and decreases down a group. Therefore, the bottom to left most element is predicted to have the lowest electronegativity, and the top right most element is predicted to have the highest electronegativity. The noble gases are not considered since they are relatively inert. How are the elements classified into different blocks in the modern periodic table? Dear children, in the modern periodic table of elements can be broken down into 4 blocks: S block, P block, D block and F block. This classification is based on the types of the orbitals that contain the valence electrons of the element. For example, S block elements have valence electrons in S orbitals. D block elements have their valence electrons in the D orbitals. What are the F block elements? Yes, F block elements are the elements of the modern periodic table whose valence electrons lie in F orbitals. These elements can be broadly classified into 2 categories, that is, the lanthanides and the actinides. Lanthanides elements whose valence electrons lie in the 4f orbital, and actinides elements whose valence electrons lie in the 5th f or 5f orbital. Dear children, now we are going to learn about the modern periodic table and electronic configuration of elements. Within a period, the neighboring elements differ slightly in their properties, while distant elements differ widely in their properties. Elements in the same group show similarity and gradation in their properties. These characteristics of the groups and periods in the modern periodic table are because of the electronic configuration of the elements, which decide the group and period in which it is to be placed. Let's see the groups and electronic configurations. Elements in the same group have the same number of electrons in their outermost shell, leading to similar valence shell electronic configuration. Thus, we observe a similar trend in the properties and chemistry of the elements in the same group. For example, the elements beryllium, magnesium, calcium belong to the group second, that is, family of alkaline earth metals. There are 2 electrons in their outermost shell. Similarly, there are 7 electrons in the outermost shell of the elements, such as fluorine and chlorine from the group 17, that is, the family of halogens. While going from top to bottom within any group, 1 electronic shell gets added at a time. From this, we can say that the electronic configuration of the outermost shell is characteristic of a particular group. However, as we go down a group, the number of shells goes on increasing. This is all about the group and electronic configuration. Now let's begin with the periods and electronic configuration. The electronic configuration of an atom is the numerical representation of the arrangement of electrons distributed in the orbitals of the atom. This determines the position of an element in the periodic table and in turn its chemical behavior. It explains how the atoms are held together by the chemical bonds and the peculiar trends which are observed in the rows and columns of the periodic table. In this article, we will discuss the electronic configuration of elements in the same periods. The value of n is nothing but the principal quantum number for the valence shell is the period of the element. Different energy levels can accommodate different number of electrons. The maximum number of electrons that a given energy level can accommodate is given by 2n2, where n is the energy level. So, the first level, that is K shell, can hold up to 2 electrons. Second level, that is L shell, can hold up to 8 electrons, and third level, that is M shell, can also hold up to 18 electrons, and so on. The first period with n is equal to 1 can hold up to 2 elements by filling the lowest level 1s. The elements are hydrogen and helium with electronic configuration 1s1 and 1s2. This marks the complete filling of K shell. The second period starts with lithium and beryllium, which have 3 and 4 electrons, and hence the last electrons enter the level 2s, and they have an electronic configuration of 1s2, 2s1, and 1s2, 2s2. You will also find that while going from left to right within the period, the atomic number increases by 1 at a time, and the number of valence electrons also increases by 1 at a time. Third period starts with sodium and ends at argon, while successfully filling 3s and 3p orbitals. 8 elements are present in this period.